Today we're going to be looking at different ways we can display various probabilities. Just like term one, or the first half, dealing with the histograms and all those other displays, there are three main types that we're going to be looking at. As you saw, some of them in Unit 4. What they are is contingency tables, Venn diagrams, and tree diagrams. So in probability, we like to have various ways to display data. The three main types of displays are, like I said, contingency tables, Venn diagrams, and tree diagrams. In this section, we're going to look at how to make each of these displays and figure out how we can use them. So the first type is called a contingency table. Contingency table is a table showing the distribution of one variable in rows and another variable in columns, used to study the association between two variables. So for example, we could sort students based on freshman, sophomore, junior, and senior, and then further break it down into male and female. So one variable along the side in rows is gender, so male and female. And then columns is class, so freshman, sophomore, junior, and senior. It is very important to note we do need total row and a total column. Those totals we are always going to use for our probabilities. The second type, as I have mentioned before, is a Venn diagram. It is a visual display to compare two or more variables. Note, for the contingency table, or sometimes called a two-way table, there's only two variables, whereas a Venn diagram is two or more. Values inside the circles are the probabilities of the event, while outside the circle are the complement. Now, just like before, note, in order for us to make them, we need to make a rectangle, because that rectangle, everything inside of it is our events. I can say this first one is group A, the second one is group B. The overlap would be A and B. So just Cliff Notes version of this, I can see total of everything inside group A is 15. Total of everything inside group B is 17. For A and B, so inside both circles, is 5. And then the complement of A and, well, A or B really, is the 7. So we have the number outside. And then our last one is a tree diagram. Tree diagram is a visual display of all possible paths two or more events could take. Now for this, I could say event 1 is getting a tails. So we start at the far left, we go to tails. And then I'll say event 2 is a heads. So I follow the path going along. And each of these has an associated probability with it. And this is kind of a visual reminder and visual way of figuring stuff out. So, example 1. Example 1 says, Fairway had a sale on ground beef and chicken breasts. On Saturday, a total of 985 people shopped there. 213 people got both the beef and chicken, while a total of 523 people got the beef, and 437 people got chicken. We're going to create a contingency table and a Venn diagram to model this. So starting off, I'll say beef is my columns. And options for beef would be, well, yes, they got beef. No, they did not get beef. And then we need our total. Meaning our side is chicken. And just like with beef, we could have, yes, they got chicken. No, they did not get chicken. And then total. Okay. Now let's start filling in information from the table that we know. So it said on Saturday, a total of 985 people shopped there. So I know my total of totals is 985. Okay. It also said 213 people got both chicken and beef. So in my yes beef column and in my yes chicken row, where they overlap, should be the 213. Because yes, they got beef and yes, they got chicken. It says a total of 523 people got beef. So in my yes beef total, be 523. And then my yes chicken row total should be 437. Now to fill in the rest of the information. I know for my beef yes column, yes, they got beef. If they got beef, they could get chicken or they could not get chicken. Those were our two options. So to get the total, I know I'd have to add my yes and yes, my yes and no. I know I have to add both of those. So to get the missing, I am going to subtract. So I'm going to do the 523 minus 213. By doing so, we get 310. Now, order really doesn't matter in this, except we do want to look at rows or columns that have two things in it at least. So for example, I can't right now do the no chicken row. I could do the yes chicken row, because I know 213 plus my no beefs have to add to the 433, or 437. So by doing subtraction again, I get 224. I could find the total of no chickens, because I know my total of yes chickens plus my total of no chickens should let me rephrase. My total of totals minus my total of yes chickens should get me my total of no chickens. By doing that, we get 548. Once again, doing subtraction, I can do the 985 minus the 523 to get 462. And in reality, to get that no chicken and no beef, we could do the 548 minus 310, or we could do the 462 minus the 224. Doing either of those will get the same answer of 238. So in reality, for a contingency table, we are going to set up the table. Then we're going to put in the numbers that we know. And from there, it's either going to be addition or subtraction. The Venn diagram, on the other hand, we first need to make a rectangle. Now, the rectangle is going to represent all possible events. And once again, in this problem, we could get chicken or beef. I'll these out a little bit. So I'm going to label my two circles, because one of that was chicken, one was beef. I'll say this first one is C for chicken, second one is B for beef. Now I'm going to pretend that we did not make this contingency table and we're just making the Venn diagram. I know that there were a total of 985 people. I'll use that number to double check my answer at the end. I know 213 people got both beef and chicken, so that 213 has to be in both circles. So it has to be in this overlap, this kind of football shape. I know this is 213. I know there were a total of 523 people total for beef. So in the whole entire beef circle, there should be 523. Well, if 213 are in that little football shape, to find out what goes in the rest of the beef, well, I'm going to do the 523 minus 213 to get 224. Because remember, the total in that beef circle should be the 523. Just like the total in the chicken circle should be 437. Well, if that total should be 437, and 213 of them are already there, once again, doing subtraction, I know that this other bit has to be 310. Now, once again, thinking, we had 985 people go to the store. They got chicken, they got beef, but we also could have the option that they did not get chicken or beef. So to find the total of people that didn't, we're going to take that total of totals, so the 985, minus each of these three numbers. So we're going to do the 985 minus 310 minus 213 minus 224. Doing so, we get 238. And that number goes on the outside. Now, majority of the time, when we have a problem like this, we're not going to make you make both a contingency table and a Venn diagram. We're going to leave the decision up to you of which you prefer to make. I would recommend leaning more towards the contingency table because that works in more situations. Okay, let's look at example 2. Create a tree diagram for flipping a coin and then rolling a 6-sided die. Then we're going to use the tree diagram to determine the probability of getting a tails and a 3. Okay, so we always start on the far left and branches out. First thing we're doing is flipping a coin. Options for flipping a coin are, well, heads or tails. Now, I also do like adding in our probability of each. So probability of heads is 1 out of 2. Probability of tails is 1 out of 2. The second event is rolling a 6-sided die. So options are 1 through 6. So I need 6 lines branching out from heads. And I need 6 lines branching out from T for tails. And then my number. 1, 2, 3, 4, 5, 6. Those are the options if I flipped and got heads first. 1, 2, 3, 4, 5, 6 options if I rolled a die after getting a tails. I know for all of those probabilities, it's going to be 1 out of 6. And if we had more events, we'd make more branches. Now, according to the problem, we want to use a tree diagram to determine the probability of getting a tails in a 3. So starting for our left, I'm going to go from my start down to tails. Since I'm at tails, then I need to go to a 3. So those probabilities, I went along a 1/2 path. And since it's an and probability, that means the times. And then I went along the 3 path, or 1/6. Multiply across, 1 times 1 is 1, 2 times 6 is 12. And there is our tree diagram. Let's look at the last example. Sample 3 said you conduct a survey that asks 500 students in your class about whether they plan to go to prom next year. 273 males respond, 100 of which say they plan to go. 86 females say they are not planning to attend. Create a contingency table for this scenario. So our 2 variables are you going to prom and gender. I'll say the top is prom. And our answers could be yes, no, and we need total. And then our variable for rows, let's say, is gender. So we could have male, you can have female, and then we need total. So go ahead and take a moment and put in the numbers where you think they go. So we asked a total of 500 people. So my total column, total row would be 500. And then it says 273 males responded. So my total males is 273. Of which those males, 100 said they plan to go to prom. Then it says 86 females say they're not planning to attend. Go ahead and take a moment, double check what you have started off with, and try the rest of the problem yourself. going through, 100 males say they are out of the total of 273. So that means I know 173 males are not going to attend. I know I asked 500 total people, 273 of which are male, meaning 227 are female. Of those 227, 86 said that they are not going to go, meaning 141 are. And then to get our total yeses, total no's, we can just add. 100 plus 141 gives me 241. 173 plus 86 gives me 259.